So the absolute value graphs, we've seen these ones, absolute value of function x. You might remember that's the one where everything below is reflected above. So we have symmetry. Well, not symmetry, it's probably a bad way of saying it, but if you were to put both graphs on the same, then you could see below flips above. So that's what I mean by symmetry in the x-axis. It's probably better to say reflection in the x-axis. Right? There's a better way of saying it. Reflect that bit of the original function where the original function is negative in the x-axis. There's random curve again. Notice I've moved the location of 1 this time. So this time our turning point there is actually smaller or above -1. So anything that is below, see you later, and reflects above. And that's all we do for function, also the absolute value of function x. So you're keeping your fingers crossed, go, please ask me absolute value of function x. That's an easy one to do. Notice, by the way, each of these x-intercepts are not turning points, they're sharp points, like the absolute value curve. Right? Because it's like you've broken it and flicked it up. Well, what about function absolute value x? Well, this time it's the y-axis. So what happens here is we reflect that part of where x is greater than 0 in the y-axis. We don't reflect over like we do with the other one. So here's random curve, function absolute value x, left-hand side, you're gone. And everything that's on the right gets reflected on the left. Because it should be an even function. Because if you're drawing function absolute value x, function negative x would be the same as function x. Because you sub it into absolute value, the negative x becomes x. So you end up with an even function. So everything on the left disappears. We reflect the right-hand side to the left-hand side. Okay. The absolute value of y is equal to function x. So what's happening now? We're saying the absolute value of y is equal to function x. This also deals with the x-axis. But this time, we reflect the part of function x where function x is positive in the x-axis. Because we're saying absolute value of y is equal to function x. So y can be both plus or minus. So here's random curve. The bit below disappears, but this time the bit above gets reflected below. Okay. Why does that happen? Let me just go back to original curve. So remember, we're saying absolute value of y is equal to function x. So the answer will be function x. Well, we can never get a negative number if we're going absolute value of y. So these answers, where the function is negative, are not possible. That's why they disappear. So those x values are no longer in the domain, but all the other x values get reflected above and below. What about if the absolute value of y is equal to function absolute value of x? We've got symmetry in both axes this time. Basically, whatever's in the first quadrant reflects into all 4 quadrants. Another way of thinking about it is, hey, how about we draw y equals function absolute value x first, and then we're going absolute value of y on that. So here's original curve. We'll end up with just what's in the first quadrant, reflected both to the left and down below. So that's absolute value of y is equal to function absolute value of x. As I say, the other way you could think about that is, if I had drawn y equals function absolute value of x, you remember what happened there? We said whatever's on the left disappears and I reflect over. But now I'm going to say absolute value of y equals that new graph. Whatever's below disappears and now gets reflected in the x-axis. So we get the same shape. All right, let's go crazy. Y equals the absolute value of function absolute value of x. Well, this one I could do by drawing y equals function absolute value x, and then saying, now I want to do the absolute value of that curve. So we'll get symmetry in the y-axis, we'll get reflection in the x-axis. There's the original graph. As I say, it's easier to draw y equals function absolute value x first, and now we'll draw the absolute value of function absolute value x. Whatever's below disappears and is reflected above. So there's absolute value of function absolute value x. Okay, let's try another. Absolute value of y is equal to the absolute value of function x. So we're going to have symmetry in the x-axis, there'll be reflection in the x-axis as well. So what will end up happening is, that bit of the original graph, where the original graph was negative, that's going to be reflected in the x-axis, then we'll reflect that result in the x-axis. So there's the original graph. There's absolute value of function x. Sorry, absolute value of function x. What do we want? We want absolute value of y is equal to that. So absolute value of y, there's y equals absolute value of function x. So, voila! Is that cool or what? There's absolute value of y equals absolute value of function x. Now I might have got a bit carried away with those. I don't know that I've ever seen them ask that one. Oh, I wish I was writing the trial for 4. That'd be a great little question, wouldn't it? It's so nice. Anyway, AD in our Cambridge, again, just a handful of absolute value ones to have a go at. See how we go.